Would you like some honest answers about whether or not your baby may have been impacted by the COVID-19 vaccine that you received during pregnancy? You are not alone. Since September 2021, there have been 613 million vaccine doses administered in the United States, many of which were to pregnant women. In the same time period, there have been an alarming increase in miscarriages, birth defects, stillbirths, and menstrual irregularities around the world. And the Mother-Child Pairings Initiative is working hard to determine the cause for all concerned mothers. If you're wondering how your baby may have been affected, then stay tuned as we walk you through the science. In the early stages of vaccine development, researchers used genomic sequencers to determine the sequence of the coronavirus and identified the spike protein as the best candidate for the vaccine. The spike protein gene was created and transcribed artificially to end up with the mRNA for a vaccine. Because mRNA is very fragile, it's coated with a fatty layer to create a lipid nanoparticle. The vaccine, which contains messenger RNA, lipids, salts, sugars, and, in the case of Moderna, acids and acid stabilizers, is then injected through the muscle. The cells absorb the lipid nanoparticles through a natural process called endocytosis, which creates a lipid bubble that, once inside the cell, bursts, releasing the messenger RNA. Normally, DNA is used as a template to make RNA through a process called transcription. However, the process can also happen in reverse, and RNA can be used as a template to make DNA through a process called reverse transcription. Studies have shown that messenger RNA from the COVID-19 vaccines is capable of undergoing reverse transcription to form a single-stranded DNA molecule. The single strand of DNA is used as a template for its partner strand, and once the double-stranded DNA is formed, it is imported into the nucleus, where there is the possibility of integration into the person's genome. If the reverse transcribed DNA incorporates into the genome of a mother's eggs, it will be passed on to their baby. The most well-known side effect of random insertional events is cancer, but any gene can be affected. If you are concerned about whether or not you may have passed on any reverse transcribed messenger RNA to your baby, a lab test can help determine that. Knowledge is power, and it's always better to be informed. Sign up for our non-invasive, fast, and accurate lab test to learn more about your family's health and experience peace of mind today.